All right, what's up everybody? I'm going to make this video to quickly go over all of the different number conversions. I am going to be assuming that you've seen this before and this is review. So if this is the first time you've seen this might be too fast. You might want to use a different resource or review your notes or watch another video. So this is going to be a quick example, just one of all the 6 number conversions. The process is going to be pretty similar for all of them, so that's why we're going to go pretty quick. So first, we're going from binary to decimal. And we're just going to look at number 1. The first thing we always like to do is label our number places. So starting at the right, we've got the ones place, and then because this is binary, we go by twos. The twos place, the fours place, and it would go on, 8, so on and so on. But these are all zeros. They don't matter. So all I care about are the 4, 2, and ones place. And then binary is pretty simple. There is a 4 because it's a 1, so I go 4. There is no 2 because it's a 0, so I can put plus 0 if I want. There is a 1 because it's a 1, 4 plus 0 plus 1. I could do that in my head, but I'll do it in my calculator. Why not? 4 plus 1 is 5. So 101 is 5. That's binary to decimal. What if you want to go back? Well, if you want to go back, you do a similar thing, but you write out the number places. And so I'll kind of do it here. I'll go the ones place, then this is binary. So the twos place, the fours place, the 8's place. And what I do is I go until it's too big. And I say, well, 8 is too big. 8 is bigger than 6. So I know that there's no 6 in there. But there is a 4 because 4 goes into 6. So I'll put a 1 in there. And then I'll keep sort of a tally. I'm fat fingering my, my calculator over here. You know what? Maybe I'll move my calculator over on the left side. Move you over here. I'm not very good with Windows yet. I'll figure it out. Maybe. I'll get you. Can go over here. Yeah, there we go. Then I'll stop fat fingering it, I hope. And so we'll do a running tally. So I've got 6, and I just took out a 4. So I'm left with 2. So I look at this and I say, well, there is a 2. And then I put in that 2, and I go minus 2, and that's 0. So I got 0 left, so there's no 1. And I can always sort of check myself, right? If I were to go backwards, well, if I go following the same logic I did in the first set of problems, 4 plus 0 plus 1, well, here I would go 4 plus 2 plus 0, and that sure is 6. Makes sense. So 6 is 110. That's decimal to binary. Okay, moving on. Hexadecimal to decimal. All right, this is probably the hardest. Wow, okay. This one is easy. A is 10. Because somewhere we've got a chart, and we know that A is 10, B is 11, C is 12, etc., etc. So I'm actually going to skip that to a slightly harder one. We'll go down to 4 here. We'll go down to 4. So what we're going to do, we're look at our 2 numbers places, just like binary. The first one's still the ones place, but because this is hexadecimal, this means base 16. It means my next place is the 16s place. If I had, say, a 3-digit number, it would go to the 256 place, and so on. Then, just like binary, this means I do have a 16, but I don't just have one 16, I have 2 16s. So I say 2 times 16 plus, and I don't just have a 1, I have C1s. And I got to remind myself, well, if A is 10, B is 11, C is 12. So I have 12 ones. So that's what the C means. The C here means I have 12 ones, just like the 2 here means I have 2 16s. So then if I do the math, 2 times 16 is 32. 12 times 1 is 12. 32 plus 12 is 44. So to C, we would write in decimal as 44. Moving on. Decimal to hex, going backwards. This one, again, I'll pick a slightly easier one, or a slightly harder one, a slightly bigger one. We're going to look at 52. Just like in binary to decimal, or decimal to binary, excuse me, we're going to start filling in our spaces. So we got the ones place, then we got the 16, and we go till we get too big. Then we got the 256, because that's 16 times 16. See, 16 times 16 is 256. Now 16 times 16, 256, that's too big. That's bigger than 52. I know that's a 0. But then I know there's some number of 16s in there, but there's more than one. How many are there? Well, that's where I divide. I do 52 over 16, and I got 3.25, and I have to round down. So I'm going to put 3 in here. And the reason I round down is then I put that into my 16s place. That's 48. So I've got 52 minus 48, which is 4. And see, 4 is too small. I couldn't have had another 16. That's why I have 3 16s. And then how many 1s? Well, this is obvious, but why not? 4 over 1 is 4. I have 4 1s. So 3 16s and 4 1s adds up to 52. Like if I did the math, I would do 3 times 16 plus 4 times 1, which would be 48 plus 4. This is just me checking my work. That is 52. Awesome. So in other words, 52 written in decimal or base 10 is the same thing as, we'll call it 32 base 16, because they both look like decimal numbers. They look like numbers we're used to, but this is base 16. So that's why we would say 32 instead of 32. Okay, now we just got binary and hex. Remember, what we always do here is we divide it into chunks of 4, and then we match it up. This chunk is obviously 0, 0, 0. This chunk, if we look at it, this is our, we can think in terms of decimal for help. 1, 2, 4, 8. 8 and 1 is 9. 9 is the same in decimal and in hex. It's just 9. So this is 0, 9. Or you could just write it as 9. To do a slightly more complex one, we'll look at 3 here. We'll dot it down. Okay, 0, 0, 1, 0. This is 2 because our only 1 is in the 2's place. Because there's no 8s, no 4s, no 1s. There is a 2, so that is 2. And then 1, 1, 1, 1. So we have something in our 8, 4, 2, 1 place. That is 15, or in hex, that is the letter F, because hex goes from 0 to F. So this is 2F. 2 is from the first part, and F is 15 is from the second part. That's where that comes from. Finally, going back from hex to binary, similarly, it's all about these chunks of 4. If I look at this one, I'm going to look at 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, 8, 1, 2, 4, 8. All right, this first one is a 1. 1's pretty easy. I know that is just 0, 0, 0, 1. A, okay, I got to remember, A is really 10. I look at 10. Well, I do need an 8, but 8 and 4 is too much. I don't need a 4. I do need a 2, because 8 and 2 is 10, so I don't need a 1. So 1, 0, 1, 0 is the same thing as A. 0, 0, 0, 1 is the same thing as 1. So 1, 1, 0, 1, 0 is the answer to that one. So it's all about breaking it into chunks of 4 and knowing our binary. I hope this video is helpful. Good luck.